Hello, everyone. Gee, Somnia. Yes, can you give me a mic check, please? Can you hear me?
Yeah, I can hear you.
Awesome. Super excited to have you all here today for today's workshop. I think let's wait for maybe 1 or 2 minutes before we start today's session. Gee, Somnia. Let's go. Yo. Super excited for this one. Today's session is very interesting, actually. If you are a Web3 developer, I'm sure you must have sometimes felt that the Web3 apps are a bit slow, static, or maybe even dependent on external factors. I mean, if you watch today's session, I'm sure that it will change the way you think about building in the Web3 space. We're calling today's session as the beginner friendly workshop on reactivity, which is Somnia's native tech. In my opinion, I would say that it's not just a workshop, it would be a glimpse to what we believe is the next generation of applications headed to. And at Somnia, we are working on some refreshing ideas on how the dApps should behave in the space. And reactivity is something which gives power to this vision. Somnia's reactivity basically gives more autonomous and real time dApp applications. Instead of applications waiting for users to rely on external systems or trigger points, uh, the apps respond instantly on their own. We have Jacek today from the Somnia's team who would be leading this workshop. So before we start the session, I would like Jacek to give a little bit of introduction about himself, and then we'll move into understanding what reactivity is and how can we build next gen applications to this amazing tech. Hi, Jacek, welcome.
Yes, my name is Jacek. I'm a protocol engineer at Somnia team. So we are working at the very core of everything. We are actually producing the software which runs the network. And yeah, this is something that we've been working since last year after we ran mainnet. And this is something that has been always missing in blockchain space. Many other people tried. There was different attempts on Ethereum, Solana, and many. Well, there was even a blockchain specialized just for the activity, and for many different reasons, technical, business, or whatever reasons, no one has else managed to have a proper reactivity on chain. What it is, why we're doing it, I will explain in short presentation, and then hopefully we'll run a demo.
I hope everybody has joined in till now. Before we start the workshop, I just want to give you a heads up that if today's workshop sparks some ideas within you, we have the Somnia's mini hackathon on reactivity live on Dora Hacks. We'll be sharing the link in the chat. So I would suggest that, after this workshop, you should go try your hands and build some cool applications on reactivity. And we'd love to see uh, interesting use cases and projects being built in this space. There are interesting prices and a lot of support from Somnia for building these projects. So looking forward to all those projects. We would also be taking questions towards the end of the session, so feel free to put them in the chat as you go. And that's it. Over to you, Jason.
Okay, perfect. Somnia Reactivity, you can go over to the docs to read more about it. But here we give a brief introduction to what it is and how it works. So, uh, if we imagine a blockchain, it's a chain of blocks, as the name indicates. Each block has a serialized number of transactions. Those transactions usually have some kind of events in EVM space, so Ethereum compatible space. We call them locks. So your transaction can emit a lock and log, and this event is something that indicates what has changed in the state as part of this transaction. Now, uh, what we can say that blockchains are passive by nature, and by that I mean that they only respond to user transactions. Right? So there's no active element on it. Then we can observe what happens on blockchain by either monitoring transactions that go in there or looking at the logs, right? But those logs are only a pull model, so you cannot subscribe to them in a native way. You can only observe them. Uh, so if you're looking for some kind of a publish subscriber model, it's not possible in a native way. You can create a smart contract which does exactly that, but it has a number of limitations that make it unreasonable to actually do. First of all, the cost, complexity, but also your smart contract will be only limited to whoever publish or subscribe to that specific smart contract. What we are looking for is a true pub-sub model when anyone can publish anything and anyone can subscribe to anything that is happening. So in a standard way, you would do it like this. You have some kind of an RPC or a node that is running in a blockchain. You this gives you some abilities to subscribe to events. You observe those subscriptions, and based on that, you can create your transaction and post this transaction to a blockchain. Now, first of all, you are either dependent on RPC provider, or you have to provide your own blockchain node or RPC server. You have to have another infrastructure to do this observability subscription thing and then create transaction based on some logic and provide execute that transaction on a blockchain. And after all of this, you still are hitting a problem. Your transaction that you create is not an immediate. It takes time, so it costs money, lots of infrastructure involved, and it still is delayed by a number of blocks before you can um, execute it. You can make your infrastructure extra smooth and limit to like 1, 2 blocks the deletion delay, but it's still delayed and requires an infra. So what else you can do is to hire a third party to do it for you. So there are a number of services. They're called either automation, Web3 hooks, Web3 actions that uh, provide kind of that functionality for you. So you go to that service, define what you are looking for, so what kind of event and how you should react to it, and then they do it for you. So they observe the blockchain and they create a transaction and post to blockchain based on your criteria. Now, usually it requires you to have some domain-specific language knowledge that applies just to that solution. There's of course some cost related to it. Uh, uh, Security. Now, someone creates a transaction on your behalf. So it's not using your private keys, it's using whoever private keys is doing the relayer service or however you call it, that service. They are creating the transaction and posting it on your behalf to the blockchain. So you have to allow them to access a specific area of your smart contracts. Um, and still, after all of that, you end up with a highly centralized solution, which depends on a provider, which could, and you hit all the problems with that kind of stuff. So availability is lower, there could be some kind of a censorship, and you depend completely on them. Uh, so these are working solutions, but they don't really give you uh, performance and a peace of mind that you would expect from a blockchain. Uh, Initially, we made an attempt to ease some of the problems people are facing. And we call it an off-chain reactivity with the mind that we always need to provide some better solution for it. So our off-chain reactivity is a Somnia watch. Watch combines two elements. So standard F subscribe and F call. In this example, we go with the standard F subscribe. We subscribe to some address like 0x28 and an event. In this case, this is a transfer event. So every time this address emits transfer event, we are going to run an F call, which could give us some additional data that we're looking for. And additionally, this F call, if call would have a context of what is happening, so the data from the event that triggered it, and you could react to it only when something changes. So you can for example, imagine a scenario when someone makes a transfers, a number of transfers, but you only react if your total balance exceeds some amount or drops below some amount. Yeah. But even with this solution, which is reasonably good because it allows you to react to event and run some custom logic based on the events before you are even notified on it. Even with this solution, if we go back, you you end up with something like this. It's better, but you still need to have some infrastructure to observe and create your transactions. So this leads us to, we hear on-chain reactivity. Now, this is extremely simplified compared to others. No external infra required, and the way it works, you make a subscription, post it to a blockchain. This subscription defines the events you're looking for and how you should respond to that event. And then, when a specific event happens, the system will create a transaction in your name because you've already given the permissions to create that transaction by subscribing to it. So it will create a transaction in your name using your address and post the transaction immediately in the same block. Uh, at the end of the block, because otherwise that would be very confusing for anyone. But in the same block, you can react to something that happened uh, on chain. So this is a proper PubSub model because anyone can publish any log or event, and anyone can subscribe to anything that is happening on chain. The reaction is instant in the same block. You can't get any better. And most importantly, it's fully decentralized, is as decentralized as your blockchain is. No extra infra required, no creation, transaction creation, no keeping your private keys somewhere on a server or whatever method you use to sign transactions. Um, and in that sense, it's secure. You control the security, you control the transactions, you can unsubscribe at any point. And more importantly is you don't use any domain specific languages and so on. You can only uh, create the whole thing in Solidity, or if you are using some Web3 TypeScript libraries, you can use Solidity and TypeScript, and that's it, really. Nothing else is required. Um, on top of it, we have some system events. So obviously, we respond to any logs from any contracts, but also you can schedule your event in time, any time in the future, or you can schedule your event to run every block, which in some would mean like 10 times a second. crazy, but maybe you do need it, or a specific block, and a specific epoch. Epoch is roughly every 5 minutes in Somnia case. Um, why would you do it? Uh, you can imagine many different use cases for the activity. I listed some of them here. So, for example, in DeFi world, you can have a trader who you really admire, and you basically want to copy everything that person is doing on chain. Uh, or, for example, you don't go as crazy. You don't want to go as crazy as that person, so you only say, "I'm copying the trades, but only 1/10 of it." Um, other stuff also DeFi related is that you can uh, stop your transactions or orders the moment you detect something on chain, or you can liquidate your position before it actually gets liquidated by the market. Uh, but it doesn't only go in DeFi world, which is the most obvious example. You can imagine many different cases, like for example in gaming, if you have data from your game on chain, for example, number of headshots, you can instantly achievements the moment they reach 100 headshots, and any kind of awards or reactions to actions that people are making in the game. Uh, uh, the other examples very much depend on the data that is available on chain, but it's not as crazy as you can think of. So there are some plans to, for example, have a F1 formula data to be available on chain, or all the flight information to be on chain. And you can imagine a scenario that uh, you buy an insurance and you get instant payout the moment your flight is delayed. Or you can bet if the moment your team scores something, or if they're losing, you think against them, or anything. Uh, then a next example, a prediction market resolution, that this is something we can combine with the other solution that we are proposed, and that's the oracles, fully on-chain oracles, which can go outside of the chain and grab some information. So the use case here is that we have a prediction market, and say at specific point in time, we gonna resolve that situation. So, for example, who wins the election, or what are the events in the real world. The blockchain will go to a specific endpoint, ask what's the answer at this point in time, and make all the payouts to anyone betting for this prediction. There's also some kind of DevOps or security examples that you can think of. For example, anytime something is deployed, you want to run an extra activity based on whatever your scenarios are. Um, so that's it. The really what is your place to play with that things. You can think of many different scenarios for this. But let me try to run some live demo on not this button, on this, and so we can see in action how it works. Uh,
Just a second. I think I need to add
yeah.
the scene. Yeah. Can you send it again? I think it wasn't added.
Okay, let me share it once more. Can you see? Perfect.
Yeah.
Um, okay, let me go through this. What's gonna happen and how our setup looks like. So first of all, we have the most basic test token that we are going to deploy, and to prove that there's no magic here, we have a transfer function here, which does the transfer and does the transfer and emits an event. Nothing more is happening. Now, we want, whenever someone makes a transfer, we want our handler to be notified of it. And it simply says it's the most basic I could come up with. When the event is triggered, whatever the event is I'm gonna raise the event count by one. As simple as that. So uh, let let me deploy. Oops, not you. Sorry. So we've deployed to this address. So this is the token. Now the event handler. Oops. Sorry. For event handler to testnet. Yeah, that should be it. Okay. Okay, so we have a token deployed to this 5E72 and the event handler to 3D25. Let me just copy it. And now let's give me a second. Let's query the event handler. Make sure. Hmm? Ah, so I got the address wrong. Oh, this is the event handler. Give me a second. Let's see if we can get the number of events. Yeah, no events. It's okay. So now let's make a transaction here. I hope you can see my screen well. Let us make a transaction. It's before we actually make any subscription. So we are making the transaction. This transaction goes out. Sorry, I've missed the zero. I hope that's the reason. Okay, so we made a transaction. Let's query our events again and confirm nothing actually has happened. No events, the get event count returns zero. So what we're gonna do now is to make a subscription. Uh, Let me show you what the subscription looks like actually. So we're going to the subscribe method. This is our subscription data, and it says whenever a transfer event is emitted, and we can look up the transfer here. What's the transfer? So the transfer event is just a from, to, and value. So whenever a transfer event is emitted on our emitter address, this is going to be a test token, then call this handler using that function selector. And there's some data like gas limits and other options. But basically what we're gonna do is to say, create a subscription. So the first parameter is the emitter, okay? So emitter is our test token. A handler is something we deployed before. Let's make a subscription. Oh, invalid. Let's see what's the problem here. I see the problem, missing 0 again. It should be it. And it created a subscription DA3. Perfect. Now, we're gonna, let's query the event count. It's still 0. Great. And we're gonna make a transfer on completely unrelated uh, contract. So we made a transfer. Perfect. It's a block number for whatever. And if we query the event count, that's one event that was recorded on a different contract. Let's make more transfers. So 1 and 2. And query the event count. 3 events in total. Yeah. So let's get the block number first quickly and see what's in the block. You can actually go to a block explorer and look up those not this. Look up those transactions. In our case, we'll just use the CLI and provide the block number. It has to be a hex. Let's go quickly change it to hex. 0x. So in this block, we had we had 3 transactions. One should be ours. So this is the transfer transaction 1D68. We have 1D68. Um, let's 1D68. So this is the transfer transaction, and we can see what's in this transaction. Oh, so I'm not sure what it did. Let me try again. Where's our transaction? 1D. This was the transaction, yeah? So we'll remove whatever is here. So what we have here, it's from this is my account to this is a token address. It's a transfer transaction, yeah, and we can confirm it by looking at the data, beginning of the data input here. This is a transfer event, a transfer function selector. But in the same block, there were other transactions. So let's have a look at this other transaction, and that should be our reaction to it. Um, let's see, is it, no, that's different. There should be one more transaction in the same block. Okay. Get by block number. So this is the transaction we're looking for, hopefully. Is it from me to, yes, this is from me, and this is our handler address, just like here. So this is my address, this is the handler. We can see exactly in the same block, a transaction has been added to a blockchain without me actually doing anything. And this transaction has the input, which contains all the information about the event, who um, emitted the event, what was the event data, and all the event topics. There's much more to it. You can subscribe to different kind of transactions, so whatever you know that contract can emit. Uh, these are the system transactions you can subscribe to, so block, epoch, and schedule. Uh, Not gonna go through it at the moment because we're kind of lacking of time, but that should be it, Lily. That presents the whole reactivity concept.
Amazing. Thank you, Jacek. Thank you so much for this insightful session. Uh, just a second. Let me change the view. All right. Uh, if you guys have any questions around whatever we've discussed today, please feel free to put them on the chat right now. Any comments on how was the workshop? Any ideas sparking in your mind? What you plan to build and reactivity? All the ideas and questions are welcome. The SDK is amazing, people say. Yes, I know. Yeah. So,
Uh,
yeah.
yeah, it's reasonably easy to set up a subscription. Uh, we're gonna make it even simpler because this kind of a data might be overwhelming, especially for someone starting with the activity. Uh, we are actually working on making it even simpler for people.
Oh, okay. Jacek, I had one question. When we
Hmm.
discuss about reactivity, it's always two types of reactivity: off-chain and on-chain, and it's always discussed how on-chain reactivity is the game changer. Can you explain the difference between the two and like what's the importance for on-chain reactivity?
Um, it really boils down to a few key factors: uh, uh, performance, uh, need for external infrastructure, security. Yeah. So uh, on-chain reactivity is instant. No delay, nothing. You react to whatever happens on-chain. It does not require any external infrastructure to run constantly and look at the blockchain events. And it is as secure, as decentralized as the blockchain itself. So no third parties involved. You can rely on it. If you rely on the blockchain, you can rely on-chain activity.
Okay, got it. And like as we know that a lot of interesting things are coming up for the future. So Somnia data streams with reactivity and whatever like AI stuff. So it's going to give more powers to the builders, right, to build amazing stuff. Mhm.
That's the whole concept. Um, in the blockchain world, we are looking. I'm talking the general space here. We are looking at the many different ways to improve it and so on. But what we are really lacking is the developer experience and the user experience. On the user experience side, there are some progress. It still could be better because I cannot imagine any new person coming in and understanding all the wallets, private keys, and so on. But it's getting better. But on developer experience front, it's in our perspective always been lacking. You always need to juggle multiple solutions, many different languages, domain specific solutions, and uh, that you cannot really get familiar yourself easily. You always need to put an extra effort to it. What we are trying to do with the things that you mentioned, so the activity, data streams, oracles, AI oracles, uh, we are making it so much easier for people to actually build on chain.
That makes sense. Well, everybody, for everyone out there, I think this session was super insightful for you as it was for me. Uh, bringing your attention again to the hackathon, which is already running till 20th of March. We've already shared the links in the chat. My teammate is also going to share the link of the Telegram community, an in house Telegram community of developers. I would encourage you all to join the community, share the ideas which you're trying to build. If you need any kind of mentorship support, we've all the team members ready to answer your questions. We would also be holding some open office hours at Discord. The announcements would be made on the social soon about this. And yes, looking forward to see what you guys are going to build. Thank you, Jacek. Thank you so much for this super insightful.
Thank you very much.
Thank you. And see you all in the next one. Have a great day. Bye.
Cheers. Bye.